Within the national curriculum, there has been a shift from learning the skills of using ICT to a deeper understanding of computer science. Miles Berry suggests computational thinking is a golden thread running through the whole of the computing curriculum. The national curriculum highlights a high quality computing education, equips pupils to use computational thinking and creativity to understand and change the world. Computational thinking is thinking about the steps we need to solve a problem and then using our technical skills to get the computer working on the problem. There are 6 concepts within computational thinking, and many of these are recognised within the computing curriculum. Logical reasoning involves using existing knowledge to make reliable predictions of how a program or computer system will behave. It also involves being able to logically explain why a program is doing what it is doing and identify why something isn't working as it should. B-bots are a useful tool for encouraging children to predict and debug their own programming. Logical reasoning can also be developed across the curriculum. For example, during literacy, children may be asked to predict what might happen next in a story. Mathematics also encourages logical reasoning, as children are encouraged to explain how they got their answer and go back through their workings out if they have made a mistake. Algorithms are a sequence of precise instructions. It involves thinking about the steps needed to get something done. It is also about finding the most efficient algorithms when solving a problem or writing a code for programming. These step-by-step instructions are used in everyday life, and it is in this way that children can find more efficient ways to get something done. This can be applied across the curriculum. For example, when cooking, children will understand that the order of the ingredients and the precise measurements of each ingredient is extremely important when following a recipe. This is the same as following the steps for getting changed for PE or following daily routines within the classroom. Decomposition is the ability to break the problem down into smaller, manageable parts. It is described as converting one big, complex problem into many smaller ones. This concept can be developed through a collaborative approach where children can work together to create an animation or video. Other cross-curricular links outside of ICT include activities such as organising a school play, solving a jigsaw puzzle, or breaking down a calculation in mathematics. Patterns can be used for a general approach for solving problems, and this is called generalisation. It is also known as finding a common solution to a common problem. These solutions are recognised and reused to get something done in the easiest and most effective way. For example, instead of writing the same block of code over and over again, children will recognise the pattern and reuse the block of code to create a single solution. This concept of finding patterns or rules can be applied across the curriculum. For example, children are taught to reuse rules for practicing spellings or when solving a problem in mathematics. Abstraction is the ability to focus on one problem at a time, ignoring the bigger picture. It enables us to simplify the problem and identify what is important. It helps us to manage the complexity of the problem without worrying about technical detail. This concept can be developed within a geography lesson. For example, children could be encouraged to draw a map of their local area, adding the places that are meaningful to them, without focusing on the detail in between. Evaluation involves making judgments based on a range of factors. It is the ability to check the solution is working efficiently and is fit for its purpose. Children are encouraged to evaluate on a daily basis, for example when evaluating their own or each other's programming on Scratch, evaluating a book they have read, or evaluating a project they have made in DT. Practical hands-on experiences which allow children to work together, experiment with problems and create solutions, support children to develop computational thinking. It is in this way that we can produce a love of learning and an interest in computing curriculum.